Today we're going to be talking about circles. And we're really going to be talking about tangents in circles. I don't know why that said just circles. This is actually about tangents. So, a tangent to a circle is a line that intersects the circle. It intersects the circle at one point. It's a point of tangency. Common tangent is a line that intersects circles at intersects two circles. Okay, they have a common tangent. I don't know if you guys heard my cat just squeal in the background. She must not like tangents. So drawing each figure, figure out if we can have any common tangents. And remember, a tangent intersects a circle at one point. So in A, if I draw a tangent somewhere out, and I know that that's not specifically tangent, that's going to hit that circle at one point, but it's never going to hit the inner circle. If I draw a tangent to the inner circle, it's a better tangent, we're going to hit at one point there, but our other one hits at 2 points. Remember, that's called a secant. Okay? Versus this here. Ooh, that's fairly decent tangent. I have a common tangent. Hits my circle at 2 points. It would be really nice if I had a ruler. If I was doing this actually in class, I'd have a ruler up on the board. Intersects both circles only at one point. So some properties of tangents. The radius of a circle is perpendicular to the tangent. So radius is perpendicular. Also, and I call this the ice cream cone theorem, tangents to a point outside the circle are congruent. That means that if AB and CB are tangents, then AB is going to be congruent to CB. So these segments are congruent. And I call this the ice cream cone theorem. I actually got this from somebody who I taught with many, many years ago. Because it's kind of like an ice cream cone. If you look at an ice cream cone, those pieces are going to be equal because you're tangent to your ice cream. Okay, polygons with all sides tangent to a circle are circumscribed polygons. So meaning that I have a point of tangency there. I have a point of tangency there. And so on. Polygons that are not circumscribed. Your circle here, yeah, it's tangent at 3 points, but it needs to be tangent at a 4th point. Okay, so this example, KL is the radius of circle K. Determine whether LM is tangent. So if we are tangent, we should have a right angle here. So let's see if our Pythagorean theorem works. Let's see if 29 squared equals 20 squared plus 21 squared. So on the left side, 29 squared is 841. On the right side, that is also 841. Yes. There's a right angle. At angle L, therefore, 3 little dots like that mean therefore. I'll write out the word therefore. I apologize. I don't know why I threw that in there. Therefore, LM is tangent to circle K. Example 3. In the figure, WE is tangent to circle D at W. Find the value of X. So we know that this is a right angle. We know that I have a right angle there. So we have one leg squared, which is X, plus another leg squared, which is 24, that equals the whole hypotenuse squared. So that equals X plus 16 squared. So now I need to solve this. I have X squared. And these are pretty big numbers. I would give you guys a calculator on this. Plus 576 is equal to X squared plus 32X plus 256. What's nice here is I subtract X squareds from both sides. I don't have to worry about a quadratic formula or anything like that. I'm going to subtract 256 over and get 320 equals 32X. X is going to equal 10. Okay, our next example. We have AB and BC are tangents to circle Z. Find the value of X. So I have tangents there. I need to find the value of X. This is our ice cream cone theorem. These two segments outside our circle are going to be equal. So AC is equal to BC, or 3x plus 2 is equal to 4x minus 3. Subtract the 3x over, and the 3 over, we get x to be 5. Our next example. The round cookies are marked in a triangular package to pique a customer's interest. If triangle QRS is circumscribed about circle T, find the perimeter of QRS. So N, M, and L are all points of tangency. So let's look and see what we have going on here. I'm going to write in green. So tangents to a point. So MS is equal to SN. So that length is 10. They tell me, I'll mark that congruent for us. They tell me NQ is 2. That tells me QL is also 2. The whole side QR is 8. One side is 2, the other side is 6, because I subtract 8 minus 2. LR is equal to MR, so that is 6. So I have a 10 and a 10, that's a 20. I have 2 and 2, that's 4, plus a 12. My whole perimeter is 36 centimeters. So that was my video on tangents. I know it was labeled circles at the very beginning, but it is tangents. Thank you for watching.